Not one tail. 2, a planet circles a distant star and leaves dust both behind it and in front of it. That is not what a small dying world is supposed to do, but the signal is there, crossing a star 140 light years away like a warning written in ash. If stories like this make your brain light up, hit subscribe and stay close. We chase the strange parts of real science, not the loudest myths, and this one may be one of the strangest planetary deaths ever caught. For a long time, planets outside our solar system were only guesses. People thought they had to be there, but nobody could point and say, there it is. Then our tools got better, and little by little, the dark started giving up its secrets. Now we know of nearly 6,000 exoplanets, which means planets around other stars. At first, many of those discoveries felt almost simple. A star would dim by a tiny amount, then brighten again, then dim again on schedule. That repeating dip told astronomers a planet was passing in front of the star. It was neat, clean, and regular, like a clock that never misses a beat. That kind of dip is called a transit. The word sounds technical, but the idea is easy. A planet moves between us and its star, blocks a little starlight, and leaves a small shadow in the data. If the same shadow comes back again and again, scientists start paying close attention. NASA built a mission called TESS to hunt for exactly that. TESS stands for Transiting Exoplanet Survey Satellite, and its job is to watch stars for those tiny drops in light. It scans huge parts of the sky and gathers light curves, which are just graphs showing how a star's brightness changes over time. Most of the time, those curves are boring in the best possible way. Then one curve was not boring at all. It came from a star called BD plus 054868A in the constellation Pegasus. A team that included researchers at MIT was checking ordinary planet candidates when this star gave them something odd. The dimming did repeat, but the shape of it looked wrong almost from the start. This matters because scientists were not hunting for a planet that was falling apart. Lead researcher Mark Hahn said they were doing a normal vetting process, just checking whether a signal looked like a real planet. Instead of a short, smooth dip, they saw a lopsided one, and instead of staying the same each time, the depth changed from orbit to orbit. That is where the mystery began to sharpen. A normal rocky planet should act like a solid object. It should cross the face of the star, make a fairly stable shadow, and move on. But this signal lingered, stretched out, and kept changing as if the object had a body and then a long, messy train behind it. So what did scientists first expect? They expected a compact planet with a clean outline. What did they actually find? They found something behaving more like a comet, except it was far too hot for normal comet ice to survive. Did you expect a planet to leave a signal like a broken brushstroke instead of a neat circle? Tell me in the comments, and if this kind of space mystery pulls you in, tap like and subscribe, because from here the story gets much harder to forget. The planet now called BD plus 054868AB is not some giant gas world. The data suggest it is a small rocky object, likely around the mass of Mercury, and maybe somewhere between Mercury and our moon in size and strength. That size is a problem because small worlds have weaker gravity. Weak gravity means they struggle to hold on when things get violent, and violent is exactly what this orbit is. The planet circles its star once every 30.5 hours. That is just over a day on Earth, which means its whole year is shorter than a weekend. It also sits about 20 times closer to its star than Mercury sits to our sun. The star is not identical to our sun either. It is a K-type dwarf star, which means it is smaller and cooler than the sun. SETI's summary says it is about 30% smaller and around 1,000 degrees Celsius cooler, but even a cooler star becomes deadly when a planet crowds it this closely. At that distance, the planet is heated to around 1,600 degrees Celsius or close to 3,000 degrees Fahrenheit, and that is hot enough to melt rock. So the surface is likely covered in magma, which is melted stone, and that magma is not staying politely on the ground. Here's the key point many people miss. The planet is not simply being smashed in one quick moment. It is trapped in a brutal orbit where heat boils minerals off the surface and its own weak gravity cannot pull enough of that material back. In other words, the star's pull set the trap and the planet is slowly losing itself inside it. Scientists first expected the main danger to be heat alone. What they actually found was a runaway process. The planet loses material, which makes its gravity even weaker, which lets it lose even more material. Why does that matter? Because once that cycle starts, the ending can speed up. Avi Sporer, one of the researchers working with the TESS Science Office, explained it in a very human way. This tiny world loses mass, its gravity drops further, and then the loss gets worse. It is a chain reaction with no rescue built into it. The planet is not healing between orbits. It is unraveling, and the amount it loses is not small. The MIT report says the planet sheds material equal to one Mount Everest every time it goes around its star. Pause on that image for a second. A mountain's worth of rocky material is leaving this world again and again, orbit after orbit. That is why the team thinks this object may not last long on cosmic timescales. They estimate it could fully disintegrate in about 1 million to 2 million years. That may sound huge to us, and it is on a human scale, but for a planet, it is more like catching a candle in its final stage of burning. If the idea of a planet losing an entire mountain each orbit sounds unreal, what do you think its sky would even look like? Drop your answer below, and if you want more real stories like this, subscribe before this one sinks in. Because the next detail is the one that turned a weird discovery into a rare one. Astronomers have found thousands of exoplanets, but only 4 known disintegrating planets like this one. All three others were spotted more than a decade ago using data from NASA's Kepler Space Telescope. That alone makes BD plus 054868AB rare, but the oddness does not stop at rarity. Most people hear dust tail and imagine one tail streaming behind the planet. That is what scientists usually expect. The paper on this world says something more surprising is happening. BD plus 054868AB appears to have both a trailing tail and a leading tail. That means dust is not only stretching behind the planet, some of it seems to be in front as well. The paper describes prominent dust tails in both directions, contributing to how the star's light is blocked. So this world is not just crumbling, it is making a messy, shifting cloud around its own path. That helps explain why the transit shape looks so strange. The transit depths seen by TESS were about 0.8 to 2.0%. Those numbers sound tiny, but for exoplanet work, that is a fairly deep bite out of a star's light. And when that bite changes shape and strength, it tells scientists the cloud is changing too. And the paper also says the dust grains are likely around 1 to 10 micrometers across, and that is extremely small, smaller than the width of a human hair by a lot. Yet even tiny grains can matter when there are enough of them. Together, they turn a planet's death into something we can read from light years away. Now hold on to this part because it is where the picture becomes almost cinematic. The tail may stretch up to 9 million kilometers long, or about 5.6 million miles. That is roughly half of the planet's entire orbit around its star. So each time this world circles, it drags an enormous smoky trail through space. Scientists first expected a planet to appear as a point-like blocker of light. What they actually found was a body plus a tail so long that the brightness of the star takes much longer to return to normal. Why does that matter? Because it means we are not only detecting a planet, we are watching a process. And there is another reason this discovery stands out. The host star is brighter and closer than the stars that host the other known disintegrating planets. That makes the system easier to study in detail. It is as if nature put one of its strangest clues under a brighter lamp. Brightness matters because better light means better measurements. So when starlight passes through the dust around this planet, different minerals can absorb different colors of infrared light, and that is where the James Webb Space Telescope comes in. Researchers planned follow-up observations with Webb to look for the chemical fingerprints in that dust. This is the part many space fans love most. A normal rocky exoplanet is almost impossible to sample directly. But this one is spilling its material into space where telescopes may study it. In a strange way, the planet is exposing itself layer by layer. Scientists first hoped exoplanet atmospheres would tell us the most. What they may get here is even weirder. Clues to the planet's crust, mantle, or maybe deeper material through its dust. Why does that matter? Because rocky planets hide their inside stories very well, and this one may be giving up its secrets while it dies. Can you imagine learning what a distant rocky world is made of because it is literally blowing itself apart? If that surprises you, hit like and tell me what mineral you think Webb might find first. And if you want more science that feels almost impossible, subscribe and stay with me. There is also a quiet detail in the discovery that deserves more attention. The paper says the host star is probably older than the sun. That makes the whole scene feel even stranger. You would expect an older system to be settled, stable, and long past its most dramatic moments. But this old system is still running a slow execution. Somehow this small planet ended up on a path that brings it disastrously close to its star. Scientists still do not know exactly how that happened. One idea is that other planets or even a companion star nudged it inward over time. And there is, in fact, a companion star in the system. The paper says an M-dwarf companion sits at a projected separation of about 130 astronomical units. That is a long distance, much farther out than Earth is from the Sun. Still, in a complicated system, even distant partners can matter over huge stretches of time. So here is another expected versus real gap. People often imagine planetary systems as clean, finished layouts that stay the same forever. Reality is rougher. Over millions or billions of years, gravity can keep reshaping orbits, pushing worlds into places they were never meant to survive. That shift in thinking is important. A planet is not only born and then left alone. It can migrate, be disturbed, be heated, be stripped, and in extreme cases, be erased. BD plus 054868AB may be showing us one of the final chapters of that process. And this is not just ancient history. This is happening now. Right now, as you listen, that planet is still making another pass around its star every 30.5 hours, still heating, still shedding dust, still changing the light we see. This is not a fossil. It is an event in progress. Picture one orbit from the planet's point of view. There is no calm sunrise, no stable ground, no weather like ours. There's a surface likely glowing with magma, rock turning to vapor, and dust being swept away into space. The planet's path is not a home. It is a furnace track. It is also worth saying clearly that crushed by gravity is only part of the truth. The star's gravity helped lock the planet into this deadly closeness, but the final destruction comes from a mix of that orbit, extreme heat, and the planet's own weak grip on its material. It is less like one punch and more like a trap that never stops tightening. If you were standing on a safe world nearby and watching the system for ages, you would never see one dramatic explosion. You would see something more haunting. A world would shrink by losing itself in pieces, leaving dust to mark every loop. That kind of slow death can feel even darker than a sudden one. And yet, for scientists, it is a gift, not because the destruction is good, but because the data are rich. The shape of the tail, the depth of the transit, the size of the grains, and the changing pattern all tell a story. Every orbit adds another sentence to it. Mark Hahn said the team got lucky catching the planet when it is really going away. Avi Sporer compared it to a last breath. Those are strong words, and they fit. In cosmic terms, this may be one of the best moments to catch such a world if you want to understand how these endings work. Here's another detail that feels easy to miss. The discovery was almost accidental. The team was not running a special hunt for a dying planet with a giant dust tail. They were doing normal planet checking, and the signal simply refused to behave. And that matters because it hints there may be more of these worlds hidden in the data. If one strange light curve can reveal a crumbling planet, others may be waiting too. The problem is that changing, messy signals are harder to find than tidy, repeating ones. Nature does not always make discovery easy. Do you think space is more unsettling when it explodes loudly or when it changes this slowly in the dark? Tell me below, and if you like stories where tiny clues reveal huge events, subscribe and turn on like support here, because the next part reaches closer to us than it may seem. At first, a doomed planet 140 light years away sounds remote enough to forget. It is not near Earth. It poses no danger to us. Nothing from its dust tail is coming here, and our planet is not about to copy its fate. But that is not the real reason this story matters. It matters because it teaches us what makes a world safe. Earth sits at a much kinder distance from the sun. Our gravity is strong enough to hold our air, our oceans, and our surface together in a stable way. When scientists study a disaster far away, they also learn the shape of the safe zone here at home. By seeing what happens when a rocky world gets too close, they better understand why our own planet is not boiling into space. Sometimes the most frightening examples teach the calmest lessons. A dying world can sharpen our gratitude for a living one. It also widens the map of what planets can be. For years, the public idea of a planet was simple, a round body calmly circling a star. Now we know planets can rain glass, spin under two suns, hide under giant atmospheres, or slowly evaporate. The universe is not interested in keeping our definitions comfortable. BD plus 05 4868 AB pushes that lesson harder than most. This is not just a hot planet. It is a world in transition from object to cloud. It still has a core body, but around that body is a moving trail of its own lost substance. There is something deeply human in the way we react to that. We hear numbers like 9 million kilometers of tail or 1 million to 2 million years left, and our minds try to turn them into feeling. So try this. Imagine seeing the remains of a place stretched halfway around its path, every orbit writing its decline in dust. And then remember that all of this was first noticed as a small dip in starlight. That is one of the most beautiful parts of astronomy. A graph on a screen can reveal a world in crisis. A tiny change in brightness can uncover a story bigger than any mountain. This is why the simplest tools often lead to the deepest shocks. No spaceship has gone there. No camera has flown past this world and looked down at its magma. And still, by reading the pattern of light carefully enough, people on Earth can tell that a planet is coming apart. Scientists first expected TESS to be great at finding nearby planets for follow-up. What they actually found here was a prime target for something even more dramatic, studying the makeup of a rocky planet through the dust of its own destruction. Why does that matter? Because direct clues to rocky exoplanet composition are rare, and rare clues can change whole fields. Future observations may show which minerals sit in that tail. If Webb can identify what kinds of rock are in the dust, scientists may compare this planet's material to the rocky worlds in our own solar system. That could tell us whether faraway planets are built from familiar ingredients or surprising ones. A world can die and still teach us how worlds are made. There's another emotional twist hidden in all this. We usually think of death as silence, but this planet is loud in the language of astronomy. Its death is visible, measurable, and patterned enough for us to study. Each orbit adds more evidence. Each dimming of the star confirms that the process is still underway. Each change in shape reminds us the dust cloud is alive with motion. What looks empty from far away is actually full of action. And maybe that is the bigger mystery space keeps handing us. The sky looks still, but it is not still. Stars flare, worlds collide, black holes feed, moons crack, and now in this case, a tiny rocky planet circles toward oblivion while carrying its own ashes. The calm view from Earth hides a restless universe. What do you think is stranger here, that the planet is dying this way, or that we can tell from a flicker of light so far away? Leave your answer in the comments, and if you want more stories where data becomes drama, subscribe and ring the bell. Because the ending of this story points straight back at us. The lesson is not that the universe is cruel. The lesson is that the universe is active. Planets are not guaranteed a peaceful future just because they formed. Their fate can depend on distance, mass, gravity, neighbors, and time. That should change how we think about the search for other Earth-like worlds. Finding a rocky planet is only the beginning. Then comes the harder question: is it stable? Is it safe? And what is happening to it right now? A planet can look promising from one angle and doomed from another. BD plus 054868 AB is almost the opposite of a habitable world. It is too hot, too close, too fragile, and too far gone. But by showing us the edge of survival, it helps define the middle ground where life might have a chance. Sometimes the dead ends on the map help us understand the roads that continue. It also reminds us how lucky we are to live at a time when these discoveries are possible. Not long ago, a story like this could not have been told at all. The planet would have lived and died unseen by us. Now, a telescope can catch its fading signal and hand that mystery to the human mind. That is a beautiful thing, even when the story is dark. A species on one small planet can learn the fate of another small planet across 140 light years. We can measure the dust, estimate the orbit, track the loss, and ask what it all means. Curiosity reaches farther than any body we have sent into space, and what it means in the end is bigger than one doomed world. It means the cosmos is full of unfinished stories. Some planets are being born, some are cooling, some may hold oceans, and some, like this one, are vanishing in real time. The sky is not a museum, it is a place where things are still happening. So when you look up next time, remember this. Somewhere in Pegasus, a tiny rocky world is still racing through a 30.5-hour year. It is still hot enough for rock to turn to vapor, and it is still dragging a tail of dust so long that it can darken its star in a way we can see from here. If that leaves you with one question, make it this one. How many more strange worlds are hidden in the data, waiting for someone to notice that one shadow does not look right? That question is not only about this planet, it is about how discovery works. Most breakthroughs do not begin with a loud announcement. They begin with someone noticing a pattern that does not fit. A light curve looks crooked, a number drifts, a signal lingers too long, and suddenly the universe opens a door nobody knew was there. So if you want more true stories like this, subscribe and turn on notifications so you do not miss the next one. And tell me in the comments, do you think Webb will reveal familiar Earth-like minerals or something far stranger in that dust tail? If this story fascinated you, share it with someone who loves space mysteries and real science. Thanks so much for watching.